Your lecture is on epigenetics in the GI tract and the effect on health and disease. So we cannot change our genes, or it's very difficult, but we can influence the function of key genes or promoter genes. And this is what we call epigenetics. Is this correct?
Yes, broadly speaking, that's correct. Epigenetics in general can be defined as any mechanism that can change a phenotype of a cell or a multicellular organism by mechanisms which are not interfering with the underlying genetic code. So a very simple example is if we take a cell from a human liver and analyze the genetic code, the DNA sequence, it will be the same as we would if we were to take a cell from a brain on the same individual. But the function and the phenotype is completely different. And broadly speaking, the mechanisms that allow that to happen are epigenetic. And so a second component to that is that not only does epigenetic sort of program individual cell function, but it can also respond to the environment.
Now, you are saying that there's specific epigenetic activity in brackets at the level of the gut epithelium. Is this proven?
Well, I would like to think that our work and the work of others has provided quite convincing and strong evidence that there is no doubt there is a close crosstalk between the gut epithelium and the environment. And obviously, one of the big environmental factors is the microbiome. And bugs that are very close in contact with the gut epithelium.
And these bugs, they switch on good epigenetic functions or bad ones?
That's for us to find out. I think whether that's good or bad remains to be proven. We hypothesize that in disease something happens that isn't good. But obviously bugs don't distinguish whether they do something good or bad.
But one effect would be if they improve immunity, local immunity at this level, that would be good.
Correct.
Is there any proof from animal models? Or?
Yes. So as a basic example, we already know that actually colonization of the intestinal tract, whether it's in mice or in humans, is required for the maturation of the intestinal epithelium. And now there is convincing evidence, in my opinion, that that process is actually, at least in part, guided by epigenetic mechanisms.
And is there any evidence from animal models that these epigenetic mechanisms can be influenced by certain probiotic strains or something, or anything else, oligosaccharides?
There is some evidence that actually bacterial products can modulate the epigenome. And also that metabolomes of gut bacteria, can actively modulate the host cell epigenome. So yes, there is evidence that will happen. So I think it's the bacteria itself that can, in some ways, reprogram the host cell epigenome. There are the downstream products, and possibly, most likely also, the nutrients and the components of food types themselves.
Last question. Breast milk has probably probiotic bacteria, whatever it is. Could they have a good influence on epigenetic mechanisms on the epithelium of the gut?
I'm convinced about that. And again, I think if we just take of what we already know from numerous studies that breast milk is protective and supportive, and it's the best for the child and the baby. I think now it's just a question of what epigenetic mechanisms are in play and prove what's already obvious.
Okay, anyway, another plea to promote breastfeeding. Thank you very much.